Okay, so I promised that I would make an attempt at a dirt battery. Dirt would just be the electrolyte in this case, a source of ions that help charge flow around. Now, after I did this, I decided I'd use tap water just as a comparison, see if dirt actually did better, and the tap water here did the same. So I decided I would use tap water for all of my samples, except for one, which is the original dirt one that I didn't want to dump out. But I additionally decided I would try throwing in some other salt ions to see if it changed anything. So a scoop of baking soda to see if more saltiness helps. And I even threw in some copper sulfate because I was like, hey, I need copper reduction to be happening. And oddly enough, it didn't change anything. So, okay, so I've got a little battery set up. And let's see how it works. Okay, so this is the original cell. It's kind of dirty because I didn't carry enough to filter it. I just threw dirt from outside into a container to see what would happen. Okay, so what we have on one end, and it's already fallen in, which doesn't actually change anything, this was a zinc screw. No guarantees it's still zinc now because of all the reactions that have been happening while I've let this sit for a week. But this is a zinc screw. And on the other side, I have just a little strip of copper. Basically what happens is that the zinc, ooh, that's got a glare. Okay, so the zinc works as the anode, which is the source of the electrons, which flows through the wire to the cathode. And you can see that zinc ions are going into solution, while copper ions should be leaving solution. This produces a voltage. When I did this, I noticed that I got a voltage of about 0.9 volts. So when I put 4 of them in series to begin with, I started with 4. I should have gotten 3.6 volts, but I was getting 2.7, which is very strange because that is a multiple of the 0.9. So it's almost like one of these was working as a straight circuit. Eventually, I sanded some stuff down and it worked, which doesn't seem to make sense, but hey, it worked, so that was fine. I got to that 3.6 number I was looking for. When I added all 6 of these together, I was expecting to get about 5.4 volts. But my actual reading was about 4.6, so it actually dropped by, again, 0.9, which is odd. But that's fine. I don't really want to spend too much time trying to tweak and fix everything. I just wanted this as a proof of concept video. Now, let's do a check, because it's been oxidizing a lot in the last week. So, like, one of these screws actually just looks, I don't think you can see it with the glare, but there's just crud all over it. Probably because I've got iron in there, and the iron's doing a reaction on the surface of the screw. Now, it doesn't necessarily matter if your stuff falls in or not, because the best redox reaction possible would be the one that's occurring, but I don't want to corrode my wires, so I tried to suspend them above, but the tape gave out, which, whatever. That's fine. And by the way, these wires are just from an old cell phone charger, well, 2 of them. I just stripped it because it didn't work anymore, and honestly I don't use micro USB, I use Type-C now. So I just stripped it, used the wires on here. I have a couple alligator clips because that was helping with something else I did. You don't need any of this. You could just strip an old wire, you could tie it onto a piece of metal, and you could drop it in solution, or you could stab it in, I don't know, a potato, mud, a lemon, something that's got ions moving around, and that will conduct electricity. So this was just, I guess, a tap water based battery, and you can see that one's blue because it's got a little bit of copper sulfate in it. Okay, so let's go ahead and check our voltage readings. It has dropped because it's been a little while, but I can probably sand it down and get the readings back. So I'm getting about 4 volts, so it's dropped about half a volt in the last week. Okay, so that's not too bad, and I can actually run this in series with other things to do some like sped up electrolysis or something, but that's okay. Okay, so what I wanted to do with this is I wanted to use it to do electroplating, but for some reason the container I was using was working, it was a glass container too, which is what's odd. It seemed to be working as a straight circuit, so I wasn't even seeing a voltage drop whenever I hooked it up, which that's my blue solution over here. But once I figure that out, I'll probably just move to a plastic container, see if that fixes it. I'm going to use this to run electrolysis, but because I am lazy and don't want to wait, I'm going to probably hook this up in tandem with another battery and probably hook it up using this old cell phone charger, which will push out 5 volts from the wall, and I will put approximately 15 volts through my current, which should hopefully plate that pretty quickly, but we'll find out. Anyways, I'll experiment with that. I will let y'all know, and then I'll probably do a video on electrolysis and electroplating. And we will see how that goes. Anyways, this is a dirt/tap water battery with, I guess, a couple other ions thrown in, which were completely unnecessary. But this is just a proof of concept. Once you hit 5 volts, you can actually charge a cell phone off of it, because cell phone chargers, like this old piece of crap, are pretty much always putting out 5 volts. That's like a standard voltage. And I wanted to do that for you, but my old phone that I was going to do it on, it wasn't wanting to cooperate, and all the old chargers I had were crap anyways. But anyways, there you go.
Okay, I want to add just a quick intermission just to kind of explain what these terms actually mean. I mentioned Ohm's law a moment ago that basically says that the voltage is equal to the current, which is measured in amps, times ohms, which is resistance. Now, to kind of have an idea of how these work, voltage is also described as electrical pressure. It's how hard the current is being pushed, or you can say it's the energy of the current. Ohms is the resistance on that, which impedes the flow of the current, and of course the current is what's actually moving. When I said that I need a certain voltage to try to speed up a reaction, that's not necessarily true. Voltage is how much pressure is required to get it to work, if we're using pressure as our term. If there's too much resistance, I need high voltage to get it to work. But increasing voltage doesn't necessarily speed up the reaction, because current is the electrons flowing. And if the current doesn't increase, the reaction doesn't speed up. But since the resistance remains the same in my circuit, effectively, increasing voltage will increase the current, and that's why I'm saying that should speed up that reaction.
Okay, so the whole purpose of this was to prove that you could do a battery out of scraps and things you can find around the house. The containers weren't entirely necessary, like they didn't have to be plastic or anything. They could have been glass containers, could have been jars. I could have just stuck it in a fruit, stuck the electrode directly into a fruit or into mud in the ground. It didn't have to be like anything fancy. Additionally, I could have just got scrap parts for everything. Instead of zinc, I could have got chunks of iron lying around. The potentials aren't as good. I used steel wool to test that earlier, and instead of getting like 0.9 volts, I think I got like 0.6 or 0.5. So it was definitely less, but you can use scrap materials to make this. For the wiring, I just stripped some old cell phone chargers, but if you have some cabling lying around, you can strip that and get many, many, many wires off of that. As long as they don't short circuit, you're good to go. And I mean, that's not too bad, and you can definitely make batteries out of scrap material, which was the whole purpose of showing you this video. Now, if you want to see more stuff like this, if you don't want me to be using scrap parts, support me on Patreon, because a few extra dollars can go a long way for me buying actual equipment so we can do some more interesting experiments. But for now, I will continue just using whatever scraps I can find to show y'all some interesting chemistry in action. Peace out, guys.